Hello everyone, welcome for this lecture. Today we are going to discuss how we can solve the numericals on KVL and KCL. Let's start with this numerical, that is find all branch currents, all branch currents and branch voltages across each resistor in the network shown below, using loop analysis, right? So now we will start solving this numerical. Okay, so just observe the numerical what they have specified in this is the first one. Let's take, so further numericals will solve to find out the loop currents and we'll try to find out the voltage drop across each resistances. Okay, so this is a very simple network, okay, which consists of two loops. This is the first loop and this is the second loop. Remember, be careful about the taking of your directions. However you have taken, you have to follow the same direction till the numerical completes. Okay, so now we have chosen this direction, like a clockwise direction. Let's solve this. Apply KVL for both the loops individually. Okay, apply KVL for first loop and apply KVL for second loop. Okay, so remember how many loops are there, those many equations you get. Okay, those many equations you get, and you have to solve those equations by using your calci, then you will get easily your answers. Okay, let's start doing it. So let's say these are two loops, first loop and a second loop. We have taken this as a loop current I1, loop current I2. Okay, and we'll apply, as we have seen there are two loops, so we get two equations. Let's apply first one. Apply, okay, apply KVL to the first loop. When you have applied KVL to the first loop, so we have to move, you have to assume that you are only moving through this loop. Okay, so in that you have to start moving by yourself, right? So when you have started, you know the direction also, which terminal of this first loop you will be reaching of a voltage source, that is negative, minus 10 volt, and always take all resistances as a positive. Okay, so then plus 0.25 into that current which is flowing through, that is I1. Okay, I1, so this is a I1. Next, another one, in this loop only you are coming to the 5 ohm resistance, so it is plus 5. But in this current is not only your observe here, this current is not, current flowing through this 5 ohm is not only your I1, there is I2 as well. Okay, how to take that? What you have to do is simply one thing, observe the direction of both. So first loop is direction like this and second current direction like this. When you have completed your first loop and you are coming in this way, so observe through the, I'll show you once. See, this current is coming in this way, I1, and this current is going in this way through this 5 ohm. Okay, I1 is coming like this, I2 is coming like this. So what you have to do is, while taking current direction, what we can write is, where you are, assume that in which loop you are, that loop current will be dominating one. Okay, if those two are opposite, right? So we'll discuss that later, but now you have to observe this current is coming like this and this current is entering like this. So what you have to do is observe these two, are they a same direction or opposite direction? These two are opposite direction, so you have to take one minus another one. Which one have to take minus and which one have to take positive? That what we have to do is assume that in which loop you are right now, means at which loop you are applying KVL, that loop current is dominating one. This one you can assume. Okay, so let's just write again. For the first loop, minus 10 volt and next plus 2.5 I1, okay, plus 5. There are two currents which are going, I1 and I2, flowing through that. So what we can do is, you are in first loop, so you take I1 minus I2. Okay, so then when you come to this, again you are reaching to a minus 10 volt, already we have written that, so nothing is left out in that loop, equal to 0. Simplify this. What we can do is, it is 2.5 I1 and it is a 5 I1, so it is 7.5 I1. Okay, next I2 is minus I2. Simplify it carefully. You can expand it and you can do. That is 5I1 minus 5I2 equal to 0, right? In the next step. And then what we can do is simplify that. 2.5I1 plus 5I1 equal to 7.5I1. And then minus 5I2. And then this minus 10 will send to equal that side. So it is equal to plus 10. Okay. Call this equation number 1. I hope you got how to get the equation number 1. Right. So let's do a similar way for a second loop. Apply KVL for the second loop. Let's see. When you applied for the second loop, alright, you are in a second loop now. Okay, you are in the second loop and that second loop current is going to dominate. Means it is greater, you have assumed that that one is greater than your I1. Okay, when the current are opposite here. Okay, so let's write. You are in a second loop, start writing. We'll start writing by 2 ohm. Okay, so it is 2I2. Next you have reached to 3. So plus 3I2, independent current is flowing there I2, and the next plus 5 ohm resistance. Okay, when you are writing this, now you are in a second loop and those two currents are opposite each other. So what we can do is I2 minus I1. Okay, no other voltage source is there. So what we can do is equal to 0. Simplify this. It is 2I1, 3I2, 5I2. How much it is? 5 plus 5. It is 10I2. Okay, 10I2. And the next you have one more, that is 5I1. That is minus 5I1 equal to 0. So write it systematically. It is 5I1 plus 10I2 equal to 0. So this is your second equation. You have got a first equation and a second equation. Solve this by Cal C, you get a answer. Right? Just observe. Applying KVL for first loop and applying KVL for the second loop. Solve these two by Cal C. You get I1 equal to 2 ampere and I2 equal to 1 ampere. When you have got I1 is 2 ampere and I2 is 1 ampere, they have told us to calculate loop currents, that is I1 and I2. Let's calculate a branch currents also, that is current through each resistances. Let's say, for example, so see this current flowing through 2.5 ohm. Okay, so observe this current, right? This is independently flowing through this 2.5 ohm, right? Therefore, current through 2.5 ohm is nothing but your I1 only, which is 2 amperes. Okay. Similarly, we have a 5 ohm resistance. Okay. Now we have a 5 ohm resistance. So current flowing through this we have to calculate. What we can do is current through 5 ohm, which is equal to, right? Observe the direction. Loop first loop is coming like this and second loop is going like this. So these two currents are opposite in direction through 5 ohm. What you can do is you can take I2 minus I1 or I1 minus I2. Both are same for us. Okay, I2 minus I1 or I1 minus I2 we can take. So if you are taking I1 minus I2, okay, if you are taking I1 minus I2, I1 is how much? 2 ampere. I2 is 1 ampere. So 2 minus 1 is 1 ampere. Current through 5 ohm is 1 ampere. Suppose if you have taken I2 minus I1, then it will be what happens? 1 minus 2. So then it is minus 1 ampere. Magnitude remains same. Only thing is negative sign comes. Meaning of this one is you have taken opposite, you have assumed the direction, what you have assumed the direction, actually it was opposite to the direction what you have assumed. Okay, so that is the meaning of a negative sign. Okay, so you can take any one among this. What I prefer is which one is greater, that current you take, and smaller one you can subtract with that. Okay, this is the current flowing through 5 ohm resistance and the current through 2 ohm resistance. This one, observe in the circuit 2 ohm. Through a 2 ohm resistance, current I2 is independently flowing, right? There is no other circuits over here. So what we can do is current through 2 ohm is nothing but your I2 and it is 1 ohm. 1 ampere current. And then what about this 3 ohm? Current through 3 ohm is also same, right? Which is independent, which is your loop current. Okay, I2, which is equal to 1 ampere. Now we'll calculate the voltage across each resistances. First voltage. So voltage across this is what? V equal to V of 2.5 ohm. Okay, V of 2.5 ohm can be calculated I into R. I is what? Current flowing through 2.5 ohms and resistance, that is 2.5 ohms. What is the current flowing through that 2.5 ohms? What is the current flowing through 2.5 ohms? It is 2, right? Into what is the resistance of that? It is 2.5. So 2.5 into 2 is 5 volts. Okay. And next, similarly, like this you can calculate for others. So let's calculate 5 voltage across 5 volts. Sorry, 5 ohms. Voltage across 5 ohms is equal to what? I into R, or else you can take R into I. Resistance is 5 ohm and I is current flowing through that 5 ohm resistance, which is 1, which is equal to 5 volts. And then 2 and 3 you can calculate. 2 is equal to 2 into, that is R into I. I is current flowing through that 2 ohm, which is 1 ampere. That you multiply with the 2 ohm resistance, you get a 2 volt. 3 ohm resistance into current flowing through that is 1 ampere. So substitute here, which will be 3 volts. Okay. So then one more thing what you can do is this, I'll overwrite on this. See, this entire circuit is of what? Like this. Okay. There is one resistance and two more. This is 2 ohm and this is 3 ohm and it is 5 ohm and it is 2.5 ohm and this is a 10 volt. Okay. Observe these three. See, this branch and this branch. All branches are parallel. Okay, this branch and this branch and this branch. What is the voltage across this branch? Total you can see. Voltage across 2 is 2 volt and 3 is 3 volts. So it is 2 volt and this is a 3 volt and those two are in series. So you can say addition of these two is 5 volt. What is voltage across 5 ohm resistance? It is 5 volt. Okay. And what about 2.5? It is a 5 volts and there is a 10. So you can take algebraic sum. It is minus 10 and this is plus 5. Or if you are coming like this, you can take 5 minus 5 and then plus 10. So if you do this subtraction, one among this, you get a 5 volt. So in all three branches, all voltage is remains same, that is 5 volts. Okay. And next we will deal with another numerical which is of a same, but suppose if we in this same numerical, if we have another one voltage source at the second loop, how to take this? Okay. So now let's solve this. Right, it's a very simple network which has 2 loops. We'll take a direction. Okay, first one you observe, prefer to take a direction like this. See, this is a voltage source from negative to positive. Okay, direction only you move like that. So direction, first one loop I'll say it is I1. Second one you can take like this or you can take this like this also. Okay, so one will solve any one by taking a direction, then another one will solve. See, earlier we have taken direction like this, another one you have taken randomly because there was no voltage source. Okay, like that also we'll take first and then we'll solve. Another one by considering this voltage source direction only, we'll take a direction like this of your I2s and then we'll solve. Okay, next step. First we'll solve by taking this. Be careful about the directions. Okay, first loop, apply KVL for the first loop. That is, in the first loop you are moving. Okay, in the first loop only you are moving. Which terminal you will reach? Minus 10 volt, right? And then you will come to second resistance, that is 2 ohm into current flowing through that, which is 2I1. Then you will come to resistance 3 ohm, where current flowing through this 3 ohm is not only I1, you have I2. So just observe the direction of both. Are they opposite? Then in which loop you are? In the first loop. So you take I1 minus I2. Okay, so another elements, no other elements, which is equal to 0. Simplify this. It is 2I1 this is 2i1 and this is 3i1, so therefore it is 5i1, and then minus 3i2 which is equal to minus 10 you send after equal to 0, then it will be equal to 10. This is your first equation. Okay, hope you have got this. 5i1 minus 3i2 equal to 10 volts. Okay, call this equation number 1, and then let's apply for the second loop. Okay, so let's apply for the second loop. Let's apply KVL for the second loop, which you have assumed the direction like this. Okay, so let's write. First one is direction like this, right? Second one is this. So let's move from the voltage source. Yes, we'll start with this voltage source. You are reaching, so observe, you are coming in this direction. Okay, you are coming in this direction, so you have reached plus 15 first. Okay, and the next plus 3 ohm resistance is there. Observe those two's current direction is opposite, so it should be one minus another one, but you are in the second loop, so you have to take I2 minus I1. Okay, and the next you have reaching 4 ohm resistance, 4 ohm, which is independent current which is flowing there, I2 which is equal to 0. Let's simplify this. 3i2 plus 4i2, how much it is? 7i2. Okay, and then there is a minus sign, 3 minus I1, so it is minus 3i1, and then plus 15 you have to send it to after equal sign. Okay, when you have sent this, it will be equal to minus 15. Let's call this equation number 2. Okay, solve this equation, both the equations, right? First equation is 5i1, okay, 5i1, right, minus 3i2 equal to 10. Second equation is minus 3i1 plus 7i2 which is equal to minus 15 when you have chosen a direction like this. Okay, be careful about it. Then by solving these two equations, you can try with this. You will get I1 is equal to 0.96 and I2 0.96 ampere. I2 is equal to 1.73 amperes. Okay, so remember these two answers. And next we'll solve by taking a reverse direction. That is, first one I'll take in this direction, and second I'll take according to the source direction. Okay, see, it is a minus and plus. I'll prefer to take from negative to positive. Okay, in that way when you have taken, so answer remains same, but what is going to change, you check. So first thing is current direction. Observe what is the current flowing through this 3 ohm resistance. Okay, when you are taking current loop 1 current, that is I1 is downward, and your I2, observe, this is also downward, means current flowing through this 3 ohm resistance is not I1, these two are in the same directions, not opposite direction. Therefore both the currents will be added, means current will be flowing together. Therefore it will be I1 plus I2. Whenever you are taking 3 ohm resistance, current through or voltage across that, okay, or current through that what you are taking, that time you supposed to be careful about the current which is flowing through that 3 ohm. Now it is not I1 minus I2 nor I2 minus I1. It is together current flowing, that is I1 plus I2. Okay, this is a simple difference. Earlier solved problem and this type problem. Okay, only thing is what we have changed is the direction. First time we have taken both the clockwise direction, and second time we are taking based on these sources. Okay, this is I1 and this is I2. Okay, let's write the equations for this. For the first KVL for the first loop, which is minus 10. Obviously you are reaching first minus 10, then plus 2 I1, okay, plus 3 ohm. Here current is what? I1 plus I2. Both the currents are flowing together. So it is I1 plus I2. Any other elements? No other elements. So is equal to 0. Just simplify this. If you simplify this, 2I1 plus 3I1 will be 5I1. Next 3 plus I2. So that is plus 3I2 will be there. Then 10 you send this side, which will be equal to 10. 5i1 plus 3i2 will be equal to 10. Okay, this is first equation, remember. Okay, let's do the second, apply for the KVL for the second loop. When you apply second loop and you have chosen a direction like this, and remember first loop current is this, second loop current is also like this. Okay, let's write the equations for this second loop. We are writing for the second loop, which is let's start from this only and then we will come back. Then we are reaching minus 15 volt, next plus 4i2 which is independent loop current, and then plus 3 their current which is flowing through, that is together. Okay, it is i2 plus i1, or you can write a i1 plus i2, both are same. Simplify this, sorry, equal to any other elements left out, 0. Then now you simplify this, it is 4i2 3i2 which gives us 7i2. Okay, and then 3 into i1 which is plus 3i1 which is equal to 15 minus 15, you send this side, which is equal to plus 15, right? So write systematically, it will be 3i1 plus 7i2 equal to 15. This, let's call this equation number 2. So solve these two equations and you get a result of a same. Okay, so let's see this. We have taken a direction like this. Okay, we have applied KVL for the first loop and you have got the equation, applied for the second loop and you have got the equation like this. When you solve this also, you get I1 equal to 0.96 and I2 equal to 1.73 amperes, which you have got where you have taken a direction like this. First one you took like this and second one you took like this. Now by which you have solved is taking direction like this. Okay, it direction will not gives, like, if you change the direction also you get the same results, but while calculating or while applying KVL and KCL, you be careful about the directions. Why these directions are remaining same? Because these are all bilateral networks. Okay, these are all bilateral networks. Okay, yeah, we'll solve another numerical. Okay, so we'll just include one more loop for this. Okay, so means 2, obviously there are 2 voltage sources are there, and then third loop we have. Therefore, as we have said, how many loops are there, those many equations you get. Okay, so let's apply for the KVL for each loop. First one, apply for the first KVL for first loop KVL. Let's move from this side. You are reaching minus 10. Okay, and then you have reached to plus 0.25 resistance. Okay, first one you have reached minus 10 volt plus 0.25 ohm resistance into I1. Okay, product of IR. And then next you have reached to 2 ohm. You have come here and then you have reached 2 ohm. Observe their currents are I1 as well as I3. You remember these two. Okay, I1 as well as I3. Observe I1 and I3, are they same direction or opposite direction? I1 is going like this, I3 is coming like this, means both are opposite. So I should take one minus another one. So I'll be taking I1 minus I3. Be careful, I1 minus I3. Okay, I1 minus I3 because I am in first loop, so I1 will be dominating, so I1 minus I3. Okay, good. Then next we'll move to another one element, that is 3 ohm. So when you are writing with respect to a 3 ohm plus 3 resistance, it is current. Observe, first loop current is downward direction and second loop current is also downward direction, means both are added, not subtracted. Okay, you please be careful about this. 3 I1 plus I2. Okay, any other element left in the first loop? No, this is equal to 0. But simplification might be a lengthy. You expand, what you can do is till you get a familiar, expand it and then write minus 10 plus 2.25 I1 plus 2 I1 minus 2 I3 plus 3 I1 plus 3 I2, and then you simplify. Okay, once you simplify this, I1 terms I'll take one side, 0.25 I1, 2 I1 and 3 I1. Total it is 5.25 I1. Okay, next I2 is how much? There is only one I2 present, that has to be multiplied by 3, so plus 3 I2. Okay, and then I3, you have one more element, that should be minus 2 I3. Okay, so this minus 10 volt will be sending to after this equal, which is equal to plus 10. Okay, so let's call this equation number 1. Remember how many loops are there, those many equations you get. By solving those many equations, you get all the loop currents. Okay, now this is first equation. Okay, let's deal with the second one. You are here now. Apply KVL. Let's start from this side. So you have reached minus 15 plus, this is a 0.25 ohm into I2. Okay, and then now plus you have come to 4 ohm resistance. Always prefer to take for the resistances as plus. Okay, and the next 4 ohm. Here what you have to do is observe direction of I2 is this side. Okay, from right to left. What about this I3? I3 also you have chosen in this direction, means current flowing through this 4 ohm resistance will be same, means together, not one minus another one, those two's direction is the same, so it should be added. You be careful about this. You are at I2, you are at a second loop, so I2 plus I3. I hope you are following this, right? And next you are reaching to 3 ohm, so plus 3 ohm. What you are doing is, here also I1 is coming like this and I2 is also coming like this. So here it should, you are at second, so I2 plus I1. Any other elements left out? No. So it is equal to 0. Now you can simplify this. First I'll write whatever you can take. You are in a second loop, so add those two. I2, 4 I2, 3 I2, 0.25 I2, 4 I2 plus 3 I2. How much total it is? 7.25 I2. Okay, 7.25 I2. And next I1 is where? It is I1. So it is plus 3 I1. Okay, what about I3? It is also plus 4 I3, which is equal to minus 15 you sent after equal, so it is equal to 15. Okay, this is your second equation. Okay, so next we'll move to third equation, that is third loop. Be careful about this. You have chosen a direction like this. We'll start with a 5 ohm. There are no voltage sources in that third loop, so obviously at last equal to 0 it is going to come. First one, it is a 5 ohm resistance, independent I3 is flowing through that. Okay, next plus 4 ohm. Observe in this again, right? So here 4 ohm, through 4 ohm current is flowing like this I3, and I2 is also coming like this. Then what you have to take is 4 into I3 plus I2 it is. Okay, next one more resistance you have, which is 2 ohm resistance, and observe this I3 is coming like this and I1 is from left to right, so both are opposite. And where you are right now, I3 will be dominating I1, so it is I3 minus I1, which is equal to, any other voltage sources you have? No, which is equal to 0. Simplify this equation by taking this 5I3, 4I3, 2I3. How much I3 is got? How much I3 is now? 9 plus 2, which is 4, 5 plus 4 plus 2 is 11 I3. Okay, plus 4 I2, next minus 2 I1, which is equal to 0. Just simplify one more time. Okay, just a simplification. I'll write as it is this equation, but systematically 1, 2, 3. That is minus 2 I1 plus 4 I2 plus 11 I3. Okay, which is equal to 0. This is your third equation. Take these three equations and then solve by calculator by taking 3 parameters equation. Then you get the result of I1 is equal to I1 is equal to 0.14178, or you can treat 8 amperes, and then I2 is it is plus 2 I2 equal to 0.2497 amperes. I3 is equal to minus 0.88 amperes. Like this you will get the answer. Okay, so suppose if we change the direction of this like this, okay, first one is okay with respect to this, the second one also I'll take like this. So then what are the main changes are going to happen? Current flowing through this 3 ohm is going to change. That is, current flowing through this 3 ohm is going to change. Observe, when you have taken direction like this, what happens here is, first current is downward direction, second current is upward. Therefore, wherever you are in the loop, if you are in the first loop, it will be current flowing through, that will be I1 minus I2. Suppose if you are at second loop, it will be I2 minus I1. Okay, this is the first change, major change. Second one is current flowing through this 4 ohm. Okay, because you have chosen direction like this, then what happens here is, current flowing through this 4 ohm in the third loop is going to change. Observe, third loop current is like this, and second loop current is like this, both are opposite. So if you are at a second loop, then you have to say current flowing through that 4 ohm will be I2 minus I3, and if you are at third loop, you have to say that I3 minus I2. Okay, these are the few changes are going to happen there, so which you need to consider. Okay, you have noted down the answer of those current loop currents. Similarly, what I'm going to say is, suppose if you change the direction, here we have assumed it. Okay, if I change the direction, what is going to happen? Observe, first loop, apply KVL for the first loop. So you are starting from voltage source, it is minus 10, next is 0.25 I1 plus 2 I1 minus I3, because these two currents are opposite, plus 3 I1 minus I2, because currents are this is downward and this one is upward. So it is I1 minus I2. Why you have taken I1 minus I2? Because you are in the first loop. So simplify this, you get this equation. Second loop, apply KVL for the second loop. Remember, this direction you have chosen like this, right? So when you take this, we can start with the 0.25 I2 plus 15, because you are reaching positive sign there, plus 15 plus 3 ohm current flowing through this is, both are opposite, so what you have to do is I2 minus I1, plus 4 ohm resistance. There also current of I3 is in this direction, and I2 what you have chosen is in this direction. Therefore, both are opposite. 4 I2 minus I3 equal to 0. Simplify this equation. Solve first equation and second equation. You get the same answer. Only thing is, I2 equal to minus 2.49, which was showing you negative sign, indicates that this is the direction what you have chosen is the opposite what it has to be. That's it. Okay, I hope it is clear for you. We have calculated loop currents. You can start calculating voltage across each resistances. Okay, that can be easily done, because you know the current flowing through each resistances. You calculate first current through each resistance and voltage across each resistance, and inform me. Okay, hope you have got this, how to apply KVL for the different loops. Thank you.